Factored finite state machines are simpler to build because we're dividing a more complex FSM into a simpler or several simpler FSMs. So we're going to factor our FSMs into smaller interacting FSMs. An example is if we want to modify that traffic light controller that we built earlier to have a parade mode. So it has two more inputs, P and R. When P is 1, we enter parade mode, and the Bravado Boulevard light stays green. When R is 1, we're going to leave the parade mode. And so here's what our unfactored FSM would look like. Would just include those additional inputs into our FSM. The factored FSM is going to say, well, you know what, we're going to have a mode FSM, and then essentially the same lights FSM that we had before. So we're going to break it up into two interacting FSMs, and we'll introduce this internal signal M that will indicate the mode of the FSM, either parade mode or regular. So here's the unfactored finite state machine, and we're not going to go over each of the transitions, but it's a mess. It's complex, it's hard to design, it's hard to debug, easy to make a mistake because of the complexity and just the sheer number of transitions. But if we factor the FSM, we can say, well, you know what, we're going to have the small FSM take care of the mode, and then we'll have essentially our same lights FSM, but now it takes into account that mode input. So as long as, for example, P is 0, it stays in this mode where it's not in parade mode, M equals 0. But if it gets a P input and it says, hey, parade mode now, it's going to output this M until it gets an R input that puts it back into the regular mode. Right, while R is 0, it stays in parade mode. And so then our lights FSM on the left says, okay, well, if I'm in the case where Bravado Boulevard gets the green, and I get this mode saying, hey, you're in parade mode now, stays there. So either the mode is saying parade mode, M equals 1, or the regular case where TB says traffic on TB. And only in the opposite case, so let's notice this, so we have M or TB, it's going to stay in S2. The opposite of that, using De Morgan's, is just M bar and TB bar, which is the case we have here. But it may be easier for you to write this as M or TB, all of it bar, so you can see, oh, yep, I have covered all the cases. I have M or TB, and I have the opposite of that covered here. And so factoring FSMs into several, in this case, two simpler FSMs is going to be easier to design, to debug, to test, and so forth.